Hello, and welcome to Global Warming, the Science of Climate Change. This is a science class. We aim to convey to a non-scientific audience a flavor for what the scientific endeavor has to say about the question of a human impact on Earth's climate. And it's kind of a cool concept for non-scientists to think about because it tends to unify. You can see a glimpse of the entire scientific enterprise kind of within the grain of sand of this small, relatively narrow question. So the question is informed by physics and chemistry and geology, atmospheric sciences, oceanography, energy systems, how social systems work, economics. You get to see a little bit of how all these different types of disciplines approach a problem, how they think, and how they work by focusing in on this fairly narrow topic. So the first half of the class time will be spent building up a conceptual, an idea model of the way the climate of the Earth works, from the very simplest possible beginning up to the full complexity of the real Earth system. It'll start with simple energy balance, with the energy fluxes being the sunlight and outgoing infrared radiation. And then we'll add a greenhouse effect. We will talk then about the temperature structure of the real atmosphere, which is determined by the process of air convecting, rising and falling, condensing water vapor, the whole hydrological cycle. And then we'll put this into the context of the global climate system, which is not everywhere the same the way we assume up to this point. There's more sun coming in at the equator than there is at the poles, and the atmosphere and the ocean both carry heat from the equator toward the poles. And so we have to simulate all the weather, the chaotic winds and currents that accomplish this process in order to understand how the climate system works. And then finally, we'll talk about feedbacks having to do with water vapor or ice freezing, different parts of the climate system that fit together in ways that either help to stabilize Earth's climate or else may act to amplify changes in Earth's climate. Then we take a break from climate physics and talk about the carbon cycle for a little while, which you can sort of imagine as various carbon reservoirs, the ocean, the land, and the solid Earth, interacting with the carbon dioxide in the atmosphere, like three sets of lungs that are all breathing with different rhythms and in different ways. And then superimposed on that, the fossil fuel carbon is an added carbon flux from the solid Earth to the atmosphere. So we'll talk about where the energy in fossil fuels comes from, what sorts of fossil fuels there are, and how they are used, and how they will impact the ongoing natural carbon cycle. Then finally, we'll talk about sort of where this leaves us. A smoking gun, which is what we call evidence that humans are having an impact on Earth's climate. The question of how much CO2 is too much. So what options do we have? And what is the prognosis? Are we doomed, or is this something that can be fixed? Anyway, so I welcome you again to this class, and I hope you find this to be of use.